Okay, this should be a pretty quick video, and I'm able to talk a little bit louder. When I made the ones last night, my daughter was sleeping in the room next to me, so hopefully you could still manage to hear it. All right, like I said, this will be pretty quick. First one is just number sense and where these things lie on a number line. So the first ones are pretty easy. You should have all this filled out in your notes anyway, because this was part of the task of, I think, 2-1 task. So you should have it done, but we can talk through it a little bit if you want to. If you got this number line stuff down, which you probably do, just skip to the next part of the video, probably a couple minutes ahead. Okay, so for these, I'll just do 8 because that's usually the toughest. So we have log 3, 3 to the 2. It's equal to 2 because, don't overthink it, 3 to the second power is 3 to the second power. So this one is 2. And actually all these are just the identity properties. So this one is -2. Let's do ones that might be a little bit tougher, like, oh, good. 7 is good. All right. So this one is 10 to what power? Oops. Is 50. Well, I know that 10 to the first power is 10, and I know that 10 to the second power is 100, and I know that 50 is kind of right in between, maybe a little closer to 10 to the first power, because 50 is a little closer to 10. So we know that it's in between 1 and 2, but a little closer to 1. So I'm going to call this one 1.4, and I'm going to mark that A. For B, we have 10 to what power is 150. I know that 10 squared is 100. And I know that 10 to the third is 1,000. And I know that 150 is way closer to 100 than it is to 1,000. Therefore, much closer to 2 than it is to 3. So I'm going to put just past 2, I'm going to have B. Log 10 1,000 is written right here. This is 10 to the third power is 1,000. And then this last one is 500, which also falls right in between these two, and pretty close to in between, actually. So I'm going to say that that's a little bit, 500 is a little closer to 100 than it is to 1,000. So we'll say right there for D. All right, next page. So the next page on here is the graphing portion, which we've done quite a bit of. So it says write an equation for each of the following functions that are transformations. Okay, so what I like to do is graph the parent function for this and then just ask myself what happened. Okay, so when I graph my parent function, I make my table, and when I'm doing log graphs, I always just write exponent and answer because it's so weird having exponents over here on this side. Now I have to include some negative exponents. Okay, if I don't, I'm not going to get the numbers down in here because those are the y, right? All right, so we have log 2x. So what is log 2x asking? It's saying 2, and then that's equal to f of x or equal to y. So it's saying 2 to the y is equal to x. So that's why these are y values, because they are going right here. So 2 to the -2 is a fourth. 2 to the -1 is a half. 2 to the 0 is 1. 2 to the 1 is 2, and 2 to the 2 is 4. I want to see this kind of thought on your test, okay? If I just see like a line or like just the equation, that might be like a little, I don't know, suspicious. I think it is doable, but just show some thought like I'm doing here, okay? So I'm going to graph this, and I'm going to have a fourth over and 2 down, half over and 1, and 1, 0, 2, 1, and I'm going to have 4, 2. And I might as well do one more. Let's do 3, 8 since we can, or 8, 3, since we can fit it on there. So it's coming down like this, and then those points are called anchor points. And now I have to start thinking about what happened. Okay, so To me, it looks like it just moved left. So to think about this, I would just be like, okay, well, this point came over here, and that's an exact point. So now I'm thinking, okay, it's a left 3. Well, does that work for all the points? And it does. Okay, so it moved left 3. So this would be f of x is equal to log 2x plus 3 in parentheses, okay? That's, remember, in parentheses, it was what moves it left to right. So if I put log 2x plus 3, that would be the same as 3 plus log 2x. These two is a vertical movement, a vertical shift of 3. All right, so that is how you do ones like number 7, and then 7a, or it's not 7, that's how you do like 12a on this one. And then you could go ahead and give 12b a shot. I don't have a ton of time right now to do this problem, but I could write on there for you the answer. Remember, this is also, it's also in your, it's in your module. So studying your module for this test would also be a really good idea. But I'm just looking up the answer key here, and the equation for this one, once you go and you do 12b, it would be negative 2 plus log 2 x minus 3. And so what that's saying is it moved, well, where did it move? Okay, it moved it right 3 and down 2. And you can kind of see how my pink one would come right 3 and down 2 to line up with that graph. Okay. But wait, now I'm looking at it and I'm starting to remember actually a mistake in the answer key, and I'm kind of intrigued because I think that this is wrong, which I'm sure some of you have pointed out. I might have to do this one after all. So the reason why I think that it is wrong is because here's my asymptote right here, coming down, approaching 0, and here it's approaching 2. So this answer key that I just looked at, I think must be wrong because this isn't moving 3 to the right. This only moved over 2 to the right. And if that's true, I would do a test point, okay? Check out the anchor point 8,3. Okay, now I'm going to move down here. I'm going to go 8,3. Now, if our hypothesis there is correct and that this is a 2 and not a 3, I should be able to go right 2, down 2, and land right on our graph. And sure enough, I do. So the answer key was incorrect, and that's the answer. All right, last one here is this kind of stuff where you have to give the same basis. You all should have the answers to every single one of these in your modules. Okay, I've done these problems multiple times now. So this is 3 to the x plus 4, and that's going to be equal to 3 to the, I think it's the 5th, right? And then you have x plus 4 is equal to 5. As soon as they have the same base, you can solve. So this one was 1/2 to the negative, good, okay, to the negative x is equal to 2 to the 3rd, which is kind of tricky because that becomes, so 1/2 to the negative x becomes this. So that becomes 2 to the x, and then 2 to the 3rd becomes 8, and x is equal to 8. This one, make them both 3/4. And then how does this 3/4 become equivalent to this? Well, I cube both numbers. For the logarithm kind, when you're solving for x, I'm going to give you a good example here. And how did we get from here to here? We added this. And then once they're the same log base, you're left with x is 5. So down here, I want this log 14 to be on the other side. And how am I going to do that? I'm going to multiply both sides by log 14. And then since these are both log base 10, remember there's no 10 written. It's 2x is 14, and then x is 7. Here you'd multiply by log 29. Here you would multiply by log 625. So I'd have log 5x minus 2 is equal to log 625. Then I have log 5x minus 3 is equal to log 5 to the 4th power. That's equal to this. And then I would have x minus 3 is 4. And then I would have x is 7. All right, hopefully that helped you out. Just some last minute skill review. Go back and watch the other videos too if you need further help at this point. Or you could come with just a couple of questions tomorrow before the test, but we really do need a lot of the period to do it. So hope that helps.